Hey there, and welcome back to Stupid Game Experiments. My current stupid experiment is building the same game in 3 of the most popular game engines: Unity, Unreal, and Godot. The game is called SH++, and it's a cross between N++ and Asteroid. This video is going to be a recap of my first week in development, but I put up new videos every single day, so make sure you hit that subscribe button to see all the latest updates. In order to develop this project in 3 different game engines at the same time, the first thing I had to do, obviously, was to install all 3 game engines. I already did a video covering the installs, so I'm not going to rehash all that now, but I'll put a link to the video up in the card thingy in the corner. My main takeaway from those 3 installs was that Godot is a much smaller game engine. Its file size is only 64 megabytes compared to Unity and Unreal, which are 8 and 15 gigabytes. This is a plus if you're using a computer without a lot of processing power, but it also means that it comes with a lot less features than the other 2. Once the engines were all installed, I created new projects in each of the game engines and set about creating a simple level to get started. This was a little more complicated than it should have been. One of my design ideas for the game is to have each level only be the size of a single screen. The problem is that screen sizes all have different resolutions, which means a map that would fit fine on one resolution would be cut off on another. Unreal Engine actually handles this perfectly fine. It resizes the view so that you never have less than the minimum view. It's possible to do the same thing in Unity and Godot as well, but you have to code it all yourself, and I haven't gotten that far yet. The flip side of this is that Unreal Engine required more effort to set up the initial scene. The Unreal Engine functionality requires that every level has certain things, like a player controller, a player pawn, game modes, etc. This meant all of these had to be set up before the initial scene would work properly without the defaults being loaded and screwing everything up. Unity and Godot have dedicated 2D setups with a camera that just works. Godot specifically works on pixels, which was nice because I wanted to build the levels on a 30 pixel grid, and with Godot this was easy to do. Unity isn't like that, and I'm still not sure the objects are sized right, but the starting 2D level worked just fine. However, I strongly suspect this is going to be a problem later on with the screen resolution issue. I may have to abandon the single screen idea and just have a camera that follows the player. This will be easier, but then I'm also sacrificing design choices due to the limitations of a game engine. After setting up the initial levels, my next step was to create the player character, which is a spaceship. The player has 4 movement controls for the spaceship. They can accelerate forward, they can rotate left or right, and they can flip 180 degrees. There is no braking option, and the spaceship floats in 0 gravity, which means it keeps moving even after the player stops pressing the forward acceleration button. For me, setting this up in Unreal Engine was the easiest, but that's at least partially because it's the engine I am most familiar with. However, it's also partially just because Unreal Engine has a lot of the code needed to do what I needed done already built into the engine. All I needed was to figure out what settings to set in order to get the result I wanted rather than trying to code everything myself. Also, for the coding I did have to do, Blueprints in Unreal is by far the easiest to use. To be fair, both Unity and Godot have visual scripting languages as well that I'm not using. However, the reason I'm not using them is because all the tutorials I found for both of those engines don't use their visual scripting languages. This isn't terribly surprising since Blueprints has been around a lot longer than either of the other visual scripting languages and is much more integrated into the engine. However, it does make it harder to use visual scripting languages in the other 2 engines. To be fair to Unity, part of the problem I have using it is I haven't set up autocomplete yet. Being able to easily discover what methods and variables are available would help me know what directions to go in to find the solutions I needed. Even still, finding what I needed wasn't overly difficult. Even if the function names aren't the same as Unreal Engine, the terminology is close enough that I could find what I was looking for. My main concern with Unity right now is that things seem to be built on a per instance basis. I created a scene and added the player. Then I added a bunch of components to that player. However, as far as I can tell, everything I set up only applies to that instance of the player. I'd have to recreate it all again in the next level. I'm sure I can code it all into a single reusable class, and maybe more advanced tutorials talk about doing that, but this seems like a really bad design practice to get in the habit of using. I'll have to see if I find a better design system as I go through more tutorials. Finally, Godot does a little better with its encapsulation. You create scenes that you can then attach scripts to and drop into other scenes. It also has an IDE with auto-completion and documentation built in, which is amazing. The problem with Godot is that its lack of features is already showing. Simple things like getting an object's forward vector have to be coded manually. On the one hand, this is an advantage. When things don't work, it is rarely caused by some engine feature somewhere that you were unaware of that you had to change. The downside, obviously, is that things done in the other 2 engines with a built-in function or changing a simple setting require being manually coded yourself in Godot. This was never unexpected, but I do expect it to get worse the farther into the project I get. So that sums up the first week of development for SH++ in Unreal, Unity, and Godot. Work on the game itself isn't moving very fast, but the comparison of the 3 game engines is moving along well. I plan on doing longer devlogs like this every Thursday, and I'm sure I'll have a lot more observations the further into development I get. However, I put out a video with shorter updates every single day, so make sure you hit that subscribe button and the notifications bell so you don't miss out. Also hit that like button if you want to see more of these side-by-side game engine comparison videos. As always, thanks for watching, and I'll see you tomorrow.